Assalamu alaikum, dear students. Students, we are starting with the topic imperfections in the solid. So first of all, crystal defect. What is a crystal defect? Internal irregularities of the crystal is known as crystal defect. Okay, so there is some defect in the crystals. It is classified into two parts: line defect and point defect. So we are going to see what is line defect and we are going to see what is point defect. In point defect, it is further bifurcated into stoichiometric defect, non-stoichiometric defect, impurity defect. Okay, so further, stoichiometric defect is of two types. It is vacancy defect, it is interstitial defect. If we talk about non-stoichiometric, we are going to have metal defect, and we are going to metal defect in the sense metal excess defect and metal deficiency defect. So we are going to see each of them one by one in this particular unit, and we are going to understand them in detail. Dear student, here we have to understand vacancy defect is somewhat relating to the Schottky defect, that is we are going to learn. Interstitial is somewhat related to the Frankel, not exactly. Okay, what is line defect? Irregularities are the irregularities or the deviation. Deviation means the movement from their place. Deviation from the ideal arrangement in the entire row of the lattice is known as your line defect. एक लाइन से पूरे पार्टिकल्स का अपनी जगह से हिल जाना, डेविएट हो जाना, इरेगुलर हो जाना, इसको हम बोलते हैं लाइन डिफेक्ट. ओके, सो दैट इज वेरी सिंपल टू बी अंडरस्टैंड. देन वी आर हैविंग अ पॉइंट डिफेक्ट. सो व्हाट इज अ पॉइंट डिफेक्ट? Point defect is the defect, or you can say the irregularities or the deviations from the ideal arrangement around the point or an atom in the crystal substance. So dear student, if we talk about the crystal and if there is any at the point, any particular point, it is having some defect, that is known as a point defect. So point defect, as I told you, we are going to have the further bifurcation, that is stoichiometric, non-stoichiometric and impurity. So we are going to start with stoichiometric defect. So dear student, what is stoichiometric defect? Point defect that do not disturb the stoichiometry of the solid is known as stoichiometric defect or intrinsic defect or thermodynamic effect. So dear student, in short, it means that this kind of the defect is not going to show the change in the number of your particular crystal formation. If one particle of the positive is missing, the another particle of the negative will also be not there when we are going to talk about the vacancy defect. In interstitial, we will be having only somewhat other than your particles may be present over there, or any one is dislocated. Okay, so here the structures are given: vacancy defect and interstitial defect. So you are able to see in vacancy defect, when some of the lattice sides are vacant, the crystal is said to have vacancy defect. When any particular site is vacant, when you don't have that particle present it over there, you call it as a vacancy defect. Dear student, this result into decrease in the density. Density is equal to mass upon volume. That is what we know. So as one particle is missing, the density will be decreased. If we talk about interstitial defect, when some constituent particles occupy an interstitial site, the crystal is said to have interstitial defect. It may be possible that any one particle is sliding at any one particular side. एक जगह वैकेंट है, उस जगह पे आपका कोई भी पर्टिकुलर कैटायन या एनायन चला जाता है अपनी खुद की पोजीशन छोड़ के, तो वी कॉल इट एज अ interstitial defect, and in this one we can say the density decreases. Okay, we are relating now with the Schottky defect and the Frankel defect. Okay, Schottky defect and Frankel defect are both different one. Now see, in Schottky defect you are able to see two boxes, means one A is missing and one B is missing. So you can say, first of all, coordination number will be high in Schottky, wherein coordination number is low in your Frankel defect. Size of the cation and anions are same in Schottky, wherein cation is smaller in the size than anion in the Frankel. Density is lowered if we talk about Schottky, but density remains same if we talk about the Frankel, because one particle is just dislocated, wherein in Schottky the two particular particles are missing. So here there is a difference lies over them. These are the points you have to remember, very important. These are asked many a times in the exam. They give the difference between the Schottky defect and Frankel Frenkel defect, or you can say it is dislocation defect. Okay, pair of the ions of the opposite charge are missing. As I told you that from the second line A is missing, then the third line B is missing, means oppositely charged particles are missing. So that is also going to maintain the neutrality कि एक प्लस गया एक माइनस गया तो न्यूट्रलिटी फिर से क्या हो गई, मेंटेन हो गई. जितना प्लस उतना माइनस बचेगा वहाँ अपने अपने क्रिस्टल्स में. ठीक है. If we talk about the Frenkel defect, ion slips into the voids into the lattice structure. मतलब एक आपका जो A है वो सेकंड लाइन में जो A है वो थोड़ा सा साइड पे चला गया है, बट आपका जो जितने प्लस है उतने माइनस है ही, तो इलेक्ट्रिकल न्यूट्रलिटी फिर से मेंटेन हो रही है. See, this is our next point. Electrical neutrality is maintained in Schottky. Electrical neutrality is also maintained in the Frenkel defect. Examples are NaCl, SCl, AgBr, AgCl, etc. अच्छा, एक important notice, AgBr and AgCl में दोनों defect पाए जाते हैं, Schottky भी और Frenkel defect भी. So ये example बहुत ही importantly याद रखना है that AgBr और AgCl में Schottky and Frenkel दोनों effect पाए जाते हैं. It is not found in the pure alkali metal halides. मतलब कि आपके जो metal halides है उसमें ये find out नहीं होता है. Due to the large size of the cations cannot accommodate into the interstitial site. क्योंकि बड़ी size की वजह से वो particle set नहीं हो पाते हैं into the voids. It is found in AgX, that is silver halide. Silver ions are smaller in their size and can get fitted into the site. आपके Ag की जो size है वो smaller है इसलिए वो कहीं पे भी fit हो जाएगी. That is why it is found. So AgX is found over there in the Frenkel defect. So dear students, this is about our stoichiometric, non-stoichiometric and impurity we will be doing in our next video. That will be the last topic of your this chapter.